So we're group 13, and for now our name is just the programmable health card.
And your presentation.
And our presentation, so we're going to start off with an overview of what we're doing, and then focus in on our hardest aspect of our project, which would be the actual card and accessing the database. So what our project is about is it's a pilot project for the existing health card. So we're trying to centralize patient information to allow it to be easily accessible, especially in case of emergencies. So doctors can access patient information without having to wait the time period necessary to request it by paper. So it's all in a centralized location. So for now, we wanted to just show you what our design, once we do the UI, would look like, and then we'll show you what we have working regarding the actual health card, our prototype health card necessary to access the patient information.
Yeah, so these are just simple mock-ups we have just to kind of give you a visualization of what we're actually doing. So we're assuming this setup would be in your actual government locations or their walk-in clinic. So say if someone's signing up for the first time and they're trying to get their new health card. So this would be for a med staff, so if they're trying to sign up onto the service, but for a patient, it would switch to this view. So you'd sign in and then you'd go to, so you're signing up. So you'd have like your first name, last name, and then date of birth and gender. So that's actually what we have for now going onto the card. So you just simply enter that information, and then from there, if you want to use the web service, it's just a simple visualization. So you could go to activity. So when you scan into everything to log in, or when you're going to a new doctor, you can see like your previous visits. And then in this instance where they're actually updating your records, they would go directly on here, so you can go back and check. So it's just to kind of give you a general idea of where we're kind of heading. And then Brandon will go through the actual card, which is our hardest aspect so far. Go through.
Yeah, sure. So this is our backend, some of our backend code, and this is what the code we use to generate a card. And this is our database right now. So we have two users. We have one person named Kevin and one person called Jotaro. And so the way that our backend code for generating the card works is we just need to place the card over here on the scanner. And on this scanner here, /reader/writer, and we need to provide our code with one of the usernames for our users. So it's just this string right here. And so when we hit run on our code, create card application, right now it's just running some security checks on the card before writing to the card. And then we will provide ourselves a username to store the information for that user to the card, hit run, and when this is done here, so the basic information that Andrew just showed us is on the card, and the way that we would kind of read this information is either from, say, a terminal or an EMT. And so I have an application on my phone that allows me to read basic information from the card. This isn't an application we made. It's just for reading from these types of My Fair cards. And so I'm just going to read it from my phone and kind of just say the information. It's on the page.
Would you guys like to see the actual thing showing up on the phone?
can probably see from over here if you just turn
It's
it.
gonna be some tiny text. So you can see here, I took the user Jotaro, and the card just has his first name, last name, date of birth. Up here, this is like this is the username associated with the card, and this is the password associated with the card.
Okay, but they might not believe me.
Oh, okay. So, let's see. This is just from reading before, but we have a username. Username. This is a password associated with the card. This is the first name, last name, and then date of birth. And so, right now, none of this information is like encrypted or secure in any way, but it's just for the sake of this demo. We do have a process in place for storing information so that I can't just like read it with my phone.
There's different security levels on the card.
Sorry?
Like different security levels within the card.
Yeah, so to add to that, if you're saying an EMT and you need to read emergency information, you would have certain keys on your device which allows you to read like basic things. And if you're a doctor, then you'd have like more information to read, like information that is necessarily needed in an emergency, such as like health record information. And so if you're a doctor, we also have this other application called the Card Authentication app. And so this one is slightly different. Right now we don't have a front end, so we only have this Java code. What you would do is you would put a card on the scanner. I'll just put an empty card on the scanner to show that this doesn't work for an empty card. So if I run this application, again, it authenticates with the card. As you can see, like all the keys again are the same thing because there's no security in place. And it's gonna get an error because the card doesn't actually have a username on it. So if we put the card that I just wrote to onto the scanner and run that one instead, you'll see that it'll basically authenticate with our backend and then print out the user information that's on the card. So you'll see information down here. The user information that corresponds to the card. So some of this information isn't on the card, such as the user's address. This is all information from our backend. And so that's basically what our proof of content is right now. Is we have like some level of authentication of the card and like writing to the card.
Okay, good.
So a few things. So new health cards you don't have to specify a gender. So I noticed that in like the GUI thing, so I didn't fix that. The encryption methods. Have you guys looked into what kind of encryption you guys are thinking of?
So when it comes to these cards, just a kind of high-level explanation of what the cards, like how this information is stored on the cards. The information is broken into blocks, and inside of those blocks you can specify which keys are required to read or write to those blocks. And the keys are, they're kind of like long passwords. Mm-hmm. So the way that the information is encrypted is, it's really not encrypted. You just need to have the key to read the information. So the card will just not allow you to read the information if you don't have the correct keys. So we plan to provide EMTs with specific keys and then doctors with specific keys. So.
Okay, but then how are the keys generated?
They're just generated randomly. I have a code that just generates them.
And then also this is just like a thought. So I noticed that when it was authenticating the blocks with the card, and I don't know if you can do this differently, but I was doing it sequentially. And if it takes that long to either register or let somebody into the system or whatever, it might be interesting if you could do it in parallel, just to speed up the authentication process. I don't know if that's possible.
It's like a hardware bottleneck. There's no way to do it in parallel because the card can only access one press at a time. But right now, writing to the card, I feel like is okay to take a couple seconds.
Yeah.
But reading, because right now we're reading. So say we have 40 blocks that we were reading from earlier. Mm-hmm. Realistically, you'd probably only read from 1 or 2 at a time. Mm-hmm. So, and if you had the keys beforehand, it would not take long.
Okay.
Yeah. The program was essentially just brute forcing to figure out if the card was blank. So reading in, let's say, a healthcare application, like in real world.
Okay.
I have a question regarding the clarification of gender. So for medical purposes, like some might need like gender.
Yeah, I'm sure they would. I just,
like,
I.
Potential for pregnancy or something like when EMT is trying to.
Yeah, and that's fine. It's just that, just when I Googled it, it was in 2016, you no longer need it for like Ontario health cards, so.
Not on like the printed card, right? So that's like the public access level.
Yeah, so I'm sure that like, I just don't know the laws that are in place in terms of like signing up for stuff like that.
Mm-hmm. But let's say if, like the doctor does have the right to access those like a patient's gender related information, or, like
Yeah.
what have they done in the past, or like, so that should be like at the appropriate level. Of
Yeah, it's
access
fine,
for
as long
that
as
medical
whatever like
professional, right?
legislation's in place that like,
Okay.
this is fine, then that's fine.
Yeah, and also I think that's something that you guys will find out and make sure that you've done your homework on it. Anything else? No. So are you never going to encrypt anything on there? Just basically it's a key that lets you access that area? Or are you going to encrypt it as well?
We haven't really thought much about it, but there's limited space on the cards. So if we, like say, encrypt the information, it might take more space potentially. So we're not. We only
Okay,
have
so
like
it's
4.
worth looking at. I'm not sure how the card works and I'm not sure how you read it, but there are some things that if you can take it apart, you can still read it. You don't have to go through the permissions to read it, right? So if it's stored in some way that you can actually just read the text without it being encrypted, then people could eventually break it quite easily. So it's something that you just need to look at, I think. If it's protected in some way and that's why they just protect the access to it, then that might be different. I don't know how they do that.
We'll look into it.
You may want to have someone whose like job it is to worry about trying to break the card and break your system.
Yep. Okay, looks good. Anything else? No?